I know. All right, I'm recording officially. That means I need to start the screen share for the Zoomers officially and still monitor the waiting room officially. So, welcome back. I have some good news for you. If you turned in your homework yesterday, which most of you did, you have nothing to do. You are caught up. Does that not feel wonderful just for even one small shining moment of being caught up? It's a mythical place. I hope to get there someday. I've heard it's nice.
It actually does feel kind of
Yeah.
good.
So yeah, I haven't put up your next homework, or your last homework yet. I haven't put up any formative assessments, anything. I just get to spend the next 2 weeks great. So, yeah. Question?
Yeah, so kind of in that vein,
Mhm.
I know if we want to, and I think a lot of us probably will, we have the option to revise the homework we
Yes.
just submitted.
Yes.
Plus, at some point, that last homework will be available too.
Yes.
In previous iterations of this course, that's
The
all
one
kind of
prettiest.
in the last part. Oh,
The one
Wow.
previous iteration of this course, you mean?
All right.
Yes, this is
Fair
the
enough.
second time I've taught it.
Do folks feel crunched to get both the new thing done plus the other one revised, or does it work out okay? Just trying to think ahead for like time budgeting
Yes.
purposes.
So the question was about revisions and whether it's, I guess, feasible to tackle a revision and a last homework. I think that's entirely up to you and how you structure your time for this class versus other classes. My intent is to have your homeworks back to you by the Tuesday after Thanksgiving so that you have 2 full weeks of classes and then finals week that you could be working on a revision.
Okay.
And I would hope to have the last homework open around the same time so that you have 3 weeks to get everything done.
Okay.
So if you want to put it off until Thursday of finals week,
No.
I would not recommend that.
Right.
But if that's what you need to do because of everything else, then you have that option.
Okay. Yeah, that's helpful.
Yes, and I will give you very specific feedback about what a revision needs to fix, as well as you'll see how many points off each thing would be and whether it's worth the effort to put it in. So as I noticed, for instance, a lot of folks did not give me a figure yet, thinking, oh, I'll do that on the revision. You get your revision back, or you get your grade back, and you're like, yeah, this is fine. I have other stuff that's more important that I need to get done than make a figure. Okay, I can live with that. But figures will eventually be useful if you're going to ever publish your results, which is why getting some practice with them is usually good. So I don't think it'll be too bad.
Yeah, no, that's helpful.
That's my answer.
Yeah.
Also, on the announcements side, before I forget, Nikki is out of town this week, so she's not having office hours Tuesday or Thursday. I'm still having mine tomorrow, and I believe Cass is. I have not heard from her otherwise. So you can still stop by and say hi. I'm never lonely, though. There's always something to do, someone to talk to. All right, so then this week, what I hope we can do is wrap up the generalized units, and then I'll decide what I want to do with the time that we have left after Thanksgiving. So nothing happening next week, no classes, no office hours, no nothing. It is a week off with respect to the academic calendar. I'll still be on email. I will be with my family probably Wednesday through Saturday. So maybe looking a little bit at email, but nothing that would be pulling focus too much. All right. So I think this is about where we were last time. We were talking about interactions, predicting binary outcomes. Does that sound about right?
Yes.
Yeah. So big picture stuff. What makes predicting a binary outcome using a multi-level model different than predicting a normal one? Pun intended and Gesundheit.
We're using logistic regression.
Yeah, we're using a logistic regression type model. And how does that differ? Yeah, I'll take gestures. The bendy line.
It unbinds, but technically binds values to be between like 0 and 1, or the probabilities.
Yes, it ensures that predicted probabilities, the probability of a 1, which is what we're predicting in binary, stays within 0 to 1, so it obeys the boundaries. That's the way I would phrase that. The link function does that specifically. Logits do that. Probits also do that. What else?
Have a different conditional distribution,
Yes.
so it's a Bernoulli distribution.
Yes, the conditional distribution for what is left over after adding fixed and random effects is Bernoulli in this case. Anything else you can think of that makes this different?
Variance, there's no level 1.
Yes, because we have a Bernoulli distribution in which there is not a separately estimated variance, we do not have a level 1 residual variance. We stick a number in there usually instead. What number is it?
Pi.
Pi squared
Over 3.
over 3, which works out to be 3.29.
I looked up why that was the case, and it involves a lot of calculus.
I'm sure that it does.
A lot of calculus.
This is where I pulled it from. If you pretend that the real underlying unobserved continuous variable that gave rise to your binary outcome has a logistic distribution, so y star is what people call that. That's the pretend underlying variable that you do not have. That variable has a variance of 3.29 if it's logistically distributed. What if it's probit instead? Do you remember that one?
Different link.
Different link? What number would we stick in for a residual variance if it's probits? It's 1. There's other ones for the asymmetric link function, so cumulative log, no, complementary, that's what it is. Complementary log or regular log. That is pi squared over 6.
Oh, it's a y.
Yes, it goes by several names, and I've tried to put them all in here. Oh, and somebody just made a good connection. I can see it. This is for if the pretend underlying distribution is skewed. But it's pretend, so who cares? There's no way we can know what it is, so we don't need to worry about that. But that's where that number comes from. Can we do pseudo R square if we're predicting the binary outcome using a multi-level model? You can try. We can do it sort of. For which level of variances could we conceivably compute pseudo R square? 1 or 2? Which level? Finger question. Typing question.
Well, we don't,
Couple votes for 2?
yeah, 'cause we don't have 1, right?
Say that again?
Didn't we just say we don't have 1?
Yes,
So
we did say that.
have to be 2 then, right?
Yes, have to be 2 then. Yes, Zoomers are saying 2 as well, yeah. So random intercept variances, random slope variances, things that vary over clusters are still estimated quantities that we can see come down after we add fixed effects that should explain them. Question?
Are the alternative link functions on that one slide, are they all 1-to-1?
This.
Yeah.
Are they all 1-to-1?
Yeah, like do they map?
They map, yes, they have the same, the mean is not 0, the mean is that. It's 0.577, and I don't know why. Don't ask me, I'm sure because math. But they work the same way in that they map the predicted probability to between 0 and 1. It doesn't go outside of that. So it accomplishes the same goal. It just does so in a way that has less faith in the part of the distribution that there's not as much information for. So if there's not that many people who have a 0, then trying to estimate this side of the regression line, like, it's not going to go as well. So it just sort of, it doesn't focus on that as much, is the way I would put it. And then green does the opposite for cases where there's not very many ones. Okay, so we can't do pseudo R square for level 1, we can't do it for level 2, and that's what I think these interactions are going to illustrate. Anything else that's different in predicting something binary? I can think of one more thing, actually 2 more things.
The thing about the variance?
The thing about the variance, I'm going to need some more words.
Yeah, because we cannot decrease level 1 residual variance. So when we add level 1 predictors, the other components must compensate that new term. So parameter estimates tend to increase.
Yes. So the idea of total variance expanding, because every time you try to predict level 1 variance, it can't decrease. So the overall before prediction amount of variance has to go up. And that makes the scale of the coefficients change.
So does that mean that adding fixed effects increases variance?
It actually does.
That's really, I don't like
It
that.
does at level 1, it doesn't at level 2, and yes, it's weird. Yeah, like my whole piles of variance thing just falls apart in this world as a metaphor. It just doesn't work anymore. I know. It's the regular price phenomenon. That's the only way that I can describe it. If you change the regular price so that you get higher percentages off, and then you're stuck with whatever the ending price of the item is. That was my advance. That's the only way I've come up with to try to explain it that makes sense. But the same thing happens in regular logistic regression as well.
So weird.
It is weird, but it is what it is. So we have that weirdness. What about the fixed effects? I need to add some more words in interpreting them in these models than usual.
They are unit specific right now.
Yeah, they're unit specific. That means that if I have a model that has, for instance, for this intercept, it has a fixed part and it has a random part, the fixed intercept is not only conditional on all the predictors being 0 like usual, it's also specific to a cluster where the random intercept is 0. Likewise, if I have a random slope, so the effect of within school math here has a fixed part and it has a random part, this fixed slope is specifically for a school whose random slope is 0. It's not the mean anymore. It doesn't work out the same. It's closer to the median than the mean from what I understand, but I don't know that there is a direct correspondence for other types of outcomes besides binary. Yes?
And maybe we've said this a different way, but then the models aren't comparable once we add those level 1 predictors.
Yes, we did not say that explicitly, but that is a consequence of the fact that the residual variance can't go down. The rest of the model variances and fixed effects have to go up, and so after you add level 1 predictors, what you had in the model before cannot be compared to what you have now. They're on different scales.
Okay.
And there are formulas by which you can try to convert them onto the same scale, but I've never bothered because I did not feel like that was a useful thing to do. But if you really needed to say, this slope is this much in this model and it's changed to be this much in that model and that means something, then they have to be put on the same scale before you can make statements like that. Yep. What's this thing we talk about? Int points.
Quadrature,
Quadrature. Give me words that go with that.
rectangles.
Rectangles.
Can't do it in R.
Uh,
Or it's not comparable to R.
Yeah, in R, it will not do more than 1 point of integration once you add a random slope in Glimmer. That is true. It switches to something called the Laplace method. So adaptive Gaussian quadrature is a way that we are integrating the random effects out so that we can figure out what fixed effects and random effect variances make the data the tallest. So those, if you're in that world, we have to pay attention to how many quadrature points are being used. Some software picks, like it looks at the problem and decides. I am fixing it to 7 to try to get the right answers that match across programs. That's why I pick 7, because that's what Stata defaults to. But that's one reason why you might get different results across packages. This means that you can do regular likelihood ratio tests. It is a true maximum likelihood solution, whereas if you pick something that's quasi-likelihood or penalized quasi-likelihood, that's not a true ML solution. So you can't use the log likelihoods to do model comparisons. And quadrature takes longer. That's the other big thing. So every time you add a random effect, you're adding like exponentially more quadrature points. Like if I have 7 in one dimension and I add a random slope, then that's 7 in the other, that's 49. And it keeps going up and up and up and up. And that's the point where Bayes might be useful, right, Nathan?
Yeah.
When ML craps out for problems that involve latent variables and link functions, broadly construed, that is when ML is likely to crap out. So crap out means not converge or behave irrationally badly, but crap out is the term that I use. So.
TM.
It is. I don't think I invented that phrase. I'm full of such phrases, but
You can still have random walks though in Bayes for.
you can still have random walks.
Yeah, like it'll get outside of its lane and then it just starts wandering and that's when all those weird like -1 billion things happen.
That's true. Bayes
So-
does not fix everything, but
No.
it can give you something when ML won't give you anything. It can give you a place to start. Okay. I think that's all that I can think of that make this different. Am I forgetting anything?
We cannot use REMO.
We cannot use REML. I did forget that. REML is not a thing in these models anymore. REML is only possible for models in which the residuals are normal at every level. So level 1 and level 2, or comparably factor analysis. Did you know that? Multi-level models are factor analysis models. Seriously. You know what a factor is? It's a random effect. Random effects are latent variables. So I've secretly been teaching you factor analysis this semester too.
Huh.
I know, right? It's crazy. Everything is a multi-level model. I just have to completely change the notation and all the words. But other than that, it's exactly the same.
The surprise was ruined because I already.
Well, good thing I'm teaching SEM in the spring if anyone wants to come join me. It's a good time, factor analysis and stuff. Okay. Yeah, no REML, but there's no REML in factor analysis, although there could
Hey,
be.
Lisa.
Yeah,
This is a random question,
okay.
just yes or no. The class that you're teaching in spring, the SEM class,
Yes.
is it the same class that Jonathan taught at Kansas?
Yes, but updated.
Okay.
So yes, you've
Okay.
already had it, I think.
Okay, sorry, I've been going back and forth because I was going to take it, and then I was reviewing my classes at Kansas, and I was like, wait.
Yeah, no, we did. We used to alternate. He taught it in his department, and I taught it in the off years in my department, and we shared the same set of slides largely. But he did R, and I only did M+. And now I have learned how to do Levon, and begrudgingly incorporated that into my class as well.
Okay, sorry, I know it was a little off topic. That's why just quick answer. Thank you.
It's not off topic. I'm the one who opened that door. But if you,
Okay.
from the perspective of latent variables and random effects are the same thing.
Okay.
There's complete overlap, and that's actually one of the topics for after Thanksgiving is item analyses.
Is there going to be anything new, like for people that have taken the course before? Will there be any? Is there
Anything new? No,
No. Okay.
no, I.
Well, no, I just in case.
No, that course is so shoved full of material that if there's anything, there's stuff that's got to come out, nothing that can be added. It's just packed. And I spent last time going through and updating all the handouts to include Levon and to add stuff. And so I'm hoping just to kind of change the dates and leave it mostly alone this time, which I never ever do, but I'm going to try. So, all right. 1250. Should we look at a model? Why not, right? Model 6. So where we were in this example is predicting binary student lunch, so whether they pay full price or they get reduced or free as the one. And we're doing it by paying attention to a student's math score, but since level 1 predictors are also level 2 predictors, we have controlled for the cluster mean, or the school mean in this context, math score as well. So what does it look like if this is my level 1 variable? What kind of model is this?
Within and between effects?
Yeah, this is a cluster mean centered level 1 predictor. So that means that no matter what else is in the model with it, I know its effect is going to be the within effect. And if it's paired with a cluster mean centered predictor in which all the level 2 information has been removed, what does that mean that the cluster mean is going to be? Between or contextual?
Yeah, between.
It's between. That's what we have here. So this is a within-between type of idea when you use cluster mean centering. We had previously added a fixed slope for cluster mean math. We had then added a fixed slope for within cluster math, tested a random slope for within cluster math, which was significant. So the extent to which math predicts free lunch differs across schools. And then we added, in this model, 2 new things right here, those 2. So the first interaction on the, it's not the first, let's go the one on the left, how's that? The one on the left, this kind of interaction has a special name. Starts with a C.
Cross level.
Cross level, why do we call it that?
Because you got a level 1 predictor interacting with a level 2 predictor.
Yeah, so this is, cluster mean math is level 2, and what it's doing in this equation, once you filter it down to beta 1 and bring beta 1 back to the level 1 equation, is multiplying school within school math. So this is within school times between school. So said differently, I'm looking to see whether or not the extent to which math predicts free lunch differently across schools depends on the school mean math score as the moderator. And if I'm going to let the within school math slope be moderated, it's only fair to let the between school math slope be moderated too, so that's what this quadratic interaction is doing. It's the complement to that. Now, do I have to have that in this model? Now, would I be smushing or committing some other sin if I didn't? I would not, but I'm putting it in here because it seems like a reasonable thing to do. So then which variance components should each of these interactions explain? How about the one that I have highlighted here? Quadratic effect of cluster mean math. Which one?
Say hesitantly.
He says hesitantly within. Okay, I've got one vote for within. I've got 2 votes via Zoom for UOC, the one in its line.
Oh, yeah,
Yeah.
that'd probably make more sense.
That's always the answer. The one in its line is always the answer. That one, random intercept. This is not a cross-level interaction. This is a level 2 interaction, by the way. How about the cross-level interaction, within by between math? Which one is it going to predict? Say it again.
Within.
No, the other one.
Wait, what?
Random slope.
Yeah, the one in its line. Still.
Okay.
But if this weren't here, then what would it be?
Within.
Then it'd be within, yeah, because then everything has to come out of E. If you don't see something in its line, it comes out of E. Yep. And we can compute pseudo R-squares for these. We can, because they were estimated to begin with, and they can come down. Yes.
Could you, because when you estimate this in other contexts, doesn't it rescale the constant variance? So could you set it up where there's like a term that rescales it and you estimate that parameter? Or is that something completely different?
Not that I know of.
Okay,
Not that I know of doesn't mean it doesn't exist.
okay.
But ideally, you would have a model where you have an estimated set of random effect variances. You introduce fixed effects at level 2 or cross-level interactions to explain them. Level 1 should stay the same. So then the model shouldn't be changing scale.
Oh, because the variance is a function of the mean, so if you start changing,
If you add something to level 1, the model changes scale. It does not if you add something to level 2.
okay.
Yeah, it's a weird halfness to it. Ba-doom. Okay.
I'm sorry.
Yeah, it's like, I'm out. I don't want to learn this anymore. Dunk. Or what more likely happened is someone's internet at home decided to quit working for no reason at all. That happens fairly frequently, it seems like. All right. See, yeah, they're coming back. Okay. We looked at these. We did these before. Do you want to do these again, or are we good with these? Interaction patterns. These are all more negatives. I can tell you that right now because these nothing but negative signs. So the within school math slope is negative. It becomes more negative in schools that have stronger math. That is significant. So that's a significant cross-level interaction. The level 2 interaction, which looks like a quadratic when you write it this way, is not significant, but it does the same thing to the between slope, makes it stronger. Just to illustrate that you can still talk about contextual effects, I asked for 2 of those. So first, if this is between, right here, CM Math 50 is giving me the between slope, WC Math is giving me the within slope, how do I get a contextual effect out of those 2 numbers?
Subtracting within to between.
Yeah, between minus within. In this case, though, it would not just be a contextual slope, but it is a conditional contextual slope given the interaction terms. So I would call it the simple slope. Specifically, when the student is at the school's average, and specifically for a school whose average is 50, given the interaction terms. That means that I could also think about a contextual interaction. So it's written in the wrong order because R is stupid. Actually, okay, no, this is Stata. I can't even bag on that. It's written in an order that doesn't make sense, but here is the cross-level interaction. So this is level 1 moderation. Here is level 2 moderation. Can you guess how I would get a contextual moderation out of that? Guess and/or read below. Same idea. Subtract them. Between minus within. So you can think of the contextual interaction as moderating the contextual effect, or you can think of it as the test of whether the within moderation and the between moderation are equivalent. In this case, there's actually very little difference. So it looks like moderation happens to the same extent between as within as a function of school mean math. So those coefficients are down here. Then I asked for some odds ratios because, you know, the world needs those. And in Stata, by the way, you can do that for lincoms. So I did that for the linear combinations of contextual effects, and the contextual interaction got odds ratios as well. In R, I had to switch to number of adaptive Gaussian quadrature points equals 1 because it wouldn't do it otherwise. That means it's using something called the Laplace method. And I will never, ever understand how you can have a quadrature point, one quadrature point, and have that be a thing. It's just never going to make sense to me. I've accepted it. It's called Laplace, and somehow it's okay. There. That's all I can say. I'm keeping it real. You know who probably knows better? The stat department. Go ask them.
It's craziness is what it is.
It is crazy, but I'm not a mathematician. It doesn't make sense to me.
Did you say to go ask the stat department?
I did.
You don't work there?
No. Well, I'm a psychologist who works in the College of Ed.
Oh, like an actual, like.
Like a real statistician,
real
like a
stat.
math stat person who did not avoid calculus in
I don't
college,
even
one
know
of
that
those
Thomas
people.
What are we then? Like, genuine question.
Applied.
Oh, Hillary,
I probably
Hillary
lost
gets
her
a
by
rim shot.
naivete.
No, it's okay. I'm laughing because she says, did you say math magician or mathematician?
Both.
Both. No, that is accurate. That is 100% accurate. It would take a magician to make this make sense to me. They would have to know some magic or some sorcery or something. But it's never going to make sense. It is what it is. In your homework, I will tell you what to choose so that I can control what you get on the backside as much as I possibly can. So that is going to make the results differ a little bit across packages. This is the thing that I was saying. R insisted on putting the quadratic terms ahead of the cross-level interaction, which actually makes more sense given the ordering of the first two things, but it's not what I had wanted. And I note that I'm getting a convergence error message, and I suspect it's because of the random slope based on the other model where the gradient for that was not very good. Using GLHT to get the linear contrast. So this is the same as usual, where this corresponds to the order of the fixed effects as you see them in the output, not as you wrote them. And then computing odds ratios for those as well. So in terms of explained variance, we captured about 16% of the random slope variance via that cross-level interaction that was significant, and we captured no random intercept variance. It actually went up a little bit. And because I'm trying to be nice to you, here's all the words that say what this means. And here's all the results section words. So now we can talk about ordinal, I think, unless there's any questions on binary. No, we're good? Okay, then I gotta switch gears a little bit. So picking up on slide 24 to get the concepts, and then I'll show you some examples. So our friend the logit is going to be used to predict other kinds of categorical outcomes, such as ordinal and nominal. And this has been my joke since at least 2012. So people on Quantitude had a show with this as the title. I was like, no, this is my joke. It's been my joke. It's mine. Yeah, I'm not going to say that they stole it from me, but I had it first. That's all I'm going to say. So too logit to quit is, of course, you know, the 90s dance reference, MC Hammer. He might have just been Hammer by that point. He tried to drop the MC to look tougher, which didn't work. But it's quite an entertaining video. It's like 20 minutes long and cost $8 billion to make. Anywho, our friend the logit is going to get us through categorical data, and the big difference is what kind of link function we pick dictates whether we are, thank you Maddie, she likes the joke, whether we are predicting ordinal or nominal. So ordinal and nominal outcomes, ordinal means ordered categories, nominal means not ordered categories, they all use the same multinomial distribution, which is the same thing as Bernoulli, but for more than one category. It has a number of categories minus one means to it and no separately estimated variance. So it'll be in the same 3.29 land for the residual variance outcome. But the difference is then the link function and how it works. So the way that ordinal link functions work, this is known as cumulative logit. It's also known as a proportional odds model, and it's also known as a graded response model in the world of IRT. All categories are represented in the model at the same time via multiple cumulative submodels. Now, this is a word that I made up for this. I don't think it's a term that other people use, but it's the best term that I can think of. Because what's going to happen is we're going to take a categorical outcome and carve it up into a series of binary outcomes. And in this cumulative link function, each category is used in each submodel. So the first submodel, if I had 4 possible categories that are ordered, would predict the logit of answering 1, 2, or 3 versus 0. The next one would predict the logit of 2 or 3 instead of 0 or 1. And the last one would predict the logit of 3 instead of 0, 1, 2. Yes?
Can you ever do it to where you have like 0, 1, 3 versus 2? Or does it always have to be in like that order?
In this link function, it's ordered. It has to stay this way.
Okay.
Here is the difficult part. And there's no way to make this less difficult. I don't think I've tried. What you get back depends on whether your software is reporting thresholds or intercepts. Now, you all know what an intercept is, right? Expected outcome when all the predictors are 0. In this context, it would be the expected probability of the higher category. So if you think about this as a binary model of red versus blue, the 1 would be the blue section and the 0 would be the red section. Thresholds give you the logit of the probability of the red, whereas intercepts give you the logit of the probability of the blue. Why that is, I need to do back a couple of pictures. I want that one. So if I have a point on a distribution where the underlying variable switches from 0 to 1, that's a threshold. So if I were to draw that on, let's see, here's one. Threshold is smack in the middle. If the proportion of zeros were more frequent, this line would move to the right. And if the zeros were less frequent than ones, this line would move to the left. So if I put the line like right here, for instance, that line reflects the proportion of zeros and then switches over to 1. So that's where this came from, is this idea of where is the dividing line on the pretend underlying variable where 0 switches to 1. But the rest of the model is always going to predict the blue. So the pieces of the model, the fixed intercepts / thresholds, may go in a different direction in terms of what's being predicted than the rest. And for single level models, like the one that's being illustrated here, I have found a way in all software programs to hack this, to make all the terms go the right way, to predict the blue to be intercepts. But I could not do it in the multi-level modeling packages. So the models are internally inconsistent in a way that is truly dissatisfying to me. But here's the good news. Go back to this picture. Remember this? Logits are symmetric about 0. So like if I have a probability of a 1 of 0.9, that's a logit of 2.2. The corresponding probability of a 0 instead would be 0.1. In logits, it's negative 2.2. So if I know the logit of the 1, the blue side, I know the logit of the other side. I just have to multiply it by -1. So that's the good news, is that even if your software gives you thresholds, you don't have to accept that. You can turn them into intercepts by multiplying by -1. So an empty model for 4 categories, would look like this, where each of the submodels would get a different intercept, and you would have to find a way to label that. So I just stuck another subscript at the end that keeps track of which submodel we're talking about. So if I'm predicting the blue, then the first submodel would say I'm predicting the logit of the probability of an answer greater than 0. the second one is greater than 1, and the last one is greater than 2. And so then each of these could be converted to the corresponding probability the usual way, e to the logit over 1 plus e to the logit. So the model is going to directly give us the probability of 3 and 0, but to get to anything in the middle, we would have to subtract. And so software will do this for you if you know how to ask for predictions. It will give you a predicted probability of every category. But the logic behind it is that the model directly gives you the probability of a 0 as 1 minus this blue part. To get to the probability of a 1, we have to go across models. So we would take the probability of 0 and 1, or excuse me, 1, 2, and 3, if I'm going this way, and subtract from it the probability of 2 and 3 to isolate the 1. Likewise, if we had the probability of 2, 3 minus 3, that gives us the probability of the 2 by itself. So these are known as indirect models for that reason, because the middle categories have to be found by subtracting across the submodels. The other thing that is dissatisfying about this that I could not fix in multi-level model land is that these models make an assumption called proportional odds. What that amounts to is that across the submodels, the slopes of all of your predictors are exactly the same. The intercepts get to be different, or they get to thresholds get to be different, but the slopes are always the same. And in single level models, there's various ways you can ask software to test it. I couldn't do it without creating like my own thing, like in Stata or in NL Mixed in SAS. So I don't have an example of how to do that. That would take a lot more coding than what I had time to create. Okay. Yeah, let's just do that. So, by the way, if you're wondering, are there other link functions that are less complicated? The answer is yes. This is the one that I wish was more common, but it's just not. It's called an adjacent category function, and it is analogous to what is known as a partial credit model in IRT land. This is much more intuitive to me. It's a conditional probability given by each submodel. Given that it's 0 or 1, what's the probability that it's 1? Given that it's 1 or 2, what's the probability of it's 2? So it's like a stair-step kind of idea. Nominal is the last option here on the bottom. This is essentially like dummy coding your outcome. You take one outcome category and designate it as a reference, and then the submodels give you the probability of each other category relative to that reference. So given that it's 0 or 1, what's the probability that it's 1? Given that it's 0 or 2, what's the probability that it's 2? So Alex, your question about can you like take the sims out, this is the type of model you'd want if you really want to focus on each alternative. And it doesn't directly compare like 1 versus 2, but you could get to that comparison by going across submodels. Or by recoding your data to change what the reference category is. That might be a little bit easier actually than trying to fight with it. Okay. So do you want to see an example of ordinal? Yeah, I know. I don't enjoy ordinal models, but they are still common enough that we need to talk about them. Oh, I made pictures. I forgot about that. Look, I made some pictures to go with the binary one. So I made a picture in Logits of kids that are low, medium, high on math and schools that are low, medium, high on math. And then I converted the predicted Logits into probabilities. So that's one thing I do want to point out is that there looks like a much bigger interaction in the second figure because the probabilities are scraping the bottom. Like this is the boundary issue showing up here. It can't go below 1. So it's just kind of curving along the bottom floor here. Okay. There. So model 7 then, in the same example, is not lumping together free and reduced lunch into one thing and treating it as an ordinal variable instead. So given that we have 3 potential categories, we have 2 submodels. Here are the original frequencies and percentages so that we can figure out what our model is doing. So I'm going to do the same thing to start with that I did for the binary, which is fit an empty model with no random effects whatsoever so that I could see how these proportions are recovered. Then I know what the model is doing. And I'm using the same style of multi-level notation as usual, where I'm predicting the logit of the higher category with an intercept that's cluster specific, and then the logit of the higher category for the second submodel with the intercept that's cluster specific. But then down here, note the minus signs. That's because what I'm going to get back are thresholds. So to turn them into intercepts that go the right way in predicting the higher category, I have to multiply them by -1. How do I know what I have? Here's the output from Stata first. I've got both packages, I think. Yep. So Stata labels these things cut 1 and cut 2. That's a threshold. These are in logits. So this is the logit of answering 0 instead of 1 and 2. This one is the logit of answering 0 or 1 instead of 2. So what it's giving you in terms of submodels is the red part here. That's what thresholds are. I can turn those into probabilities. For instance, e to the logit over 1 plus e to the logit gives me a probability of 0.6925. Lo and behold, that matches the probability of a 0. So that's how I know what it means. The other probability, if I convert that from logits to probability, is 0.779. And that's what you get if you add these two together. So the cumulative frequency is right here. So that's what the cuts do, is they sort of work your way up the categories. But what they mean is the probability that goes with the lower option, which is weird. Okay. In R, I had to switch packages, so I am using a function called CLM from a package called Ordinal to do this. It wanted me to turn my categorical outcome into a factor variable, so I said, okay, I'll do it in the model. Just 1 here, but it knows in this function that you mean 1 per submodel. So the code and what happens are not really matching up at this stage. Here's what I get back. O/1 and then 1/2. That is also not accurate. That wording implies an adjacent category link and not a cumulative link. What it should be is this.
It should be what?
Okay, I'll do it again. Okay.
Oh, okay, I saw what you did.
Okay. Okay, this is what came out of R, but this is incorrect. If it wanted to label these correctly, this is what it should have done. These are cumulative submodels, not adjacent category submodels. The latter, adjacent category, is conditional. It would mean of the people who answered 0 or 1, here's the logit of a 0, but that's not what these numbers mean. So we get the same answers that we did out of Stata at this stage, which, well, we should. There's no difficulty in estimation here, so I can turn those into probabilities, and there they are. Okay, take those out. Next step, adding a random intercept. How many random intercepts do you think I'm going to have?
1 minus the number of categories minus 1.
You would think. Nope. I have number of categories -1 fixed, intercept/threshold things. Here's a hint. Same symbol.
How a number of clusters.
1 random intercept variance across clusters. And it operates across all the submodels equally. This is part of proportional odds that happens. The random effects you get 1 of, and all submodels share it. So after adding in a random effect, my cuts thresholds have changed slightly. The probabilities no longer match the raw data because these things are unit specific. So these are the expected logit of the lower category, specifically for a school with a random intercept of 0. Those frequencies work out to be a little bit higher. 0.77 and 0.85 are the cut points for that. In R, I'm using CLMM, which I think one of those M's stands for either multi-level or mixed or something like that. But the syntax looks the same as usual in terms of adding a random effect. R agrees there's only one new variance, and it will compute an inter-class correlation using 3.29 as residual variance in the usual way. So 3.35. So 35% of the variance in lunch is related to schools, which is significant. Okay, now here comes the fun part. I'm going to add in main effects of within school math and between school math, just like we did in the other models, although I'm skipping one step. Note the subscripts on here. This is me trying to notate this correctly. I stuck an extra 1 or a 2 on the terms that vary across submodels, but you'll notice most of them don't. The only thing that varies across submodels is the fixed threshold. Everything else is the same. So here's the status solution. Cut 1 is still the logit of the probability of answering 0 instead of 1 or 2. So what does that mean in this context? What are we predicting?
The probability of free or reduced lunch.
Yeah, we're predicting lunch, and 0 means they paid. So this corresponds to the logit of the probability of paying for lunch for the reference predictors. School with a math of 50 for a student whose math is equal to their school's mean, and random intercept of 0. This one then is the probability of 0 or 1, which is lumping together paid or reduced versus free. Do I have that out here? Yes, I do. Okay. Now, what do you think these two slopes are predicting?
Both things.
Both things. Which way do they go? Are they predicting the lower category, or are they predicting the upper category?
The lower, well, you change or flip that symbol, right? So they were positive if they were predicting thresholds. They are negative if they are predicting the upper categories.
Yep. Here is the weirdness. Oh, we got Zoomers are guessing. One guess upper, one guess lower. You would think the whole model is predicting the lower, and you would be wrong. And that's why this makes me insane. These are predicting up. These are predicting the logit of the higher category within each submodel. So the first one, the first submodel is 0 versus 1, 2. It would be predicting the logit of some kind of discounted lunch. In the second submodel, it would be lumping together paid and discounted against free. And yeah, these are negative, just like we saw in the binary models, because they are predicting the higher category, as in binary was predicting the 1. So to summarize, these thresholds are predicting the lower of the possibilities in each submodel, whereas all slopes are predicting the upper. And if you're like, oh my God, how do I explain this to my reader? Can I please have intercepts? How do I make them intercepts?
Multiply by -1.
There, fixed it. And maybe that's why the software was like, no, I'm not going to do that for you. Just add your own damn minus signs. It's fine. But yes, now these are intercepts. So if you multiply your thresholds by -1, then the whole model is going the same way. It is predicting the upper category. But not that. So are these predicting the logits of 1 and 2 instead of 0, or 2 instead of 0 and 1?
I would say both at the same time.
Yeah, the answer is yes. Yes, they are. Both at once. That's the proportional odds assumption, still alive and well. We are saying that the effect of math in predicting the probability of a lunch outcome does not care which lunch outcome we're predicting. Seems very dissatisfying. It's a testable hypothesis, it's just very difficult to test it. At least in built-in software. You'd have to roll your own, as Jonathan would say. You know, he did a Bayesian podcast the other day, and I listened to it.
Yeah.
And he was talking about how back in graduate school you didn't have, like, we didn't have JAGs, we didn't have STAN, we didn't have all these things. And so he told the person, yeah, I pretty much had to roll my own. I was like, oh, that's one way to put it. So yeah, I didn't want to roll my own because this is enough, but that's what you would have to do to actually test it. You'd have to work within a framework that allows you to write your own model, write out the likelihood function, and then customize it to your heart's content. I know how to do that in SAS and LMixed. I don't know how to do that in other packages, but it is possible. All right, contextual slope, odds ratios, et cetera, et cetera. Can we do random slopes? Sure, we could. We could do one of those. I have a note here that I tried to get contextual effects out of R and it just wouldn't work. And I tried everything I could possibly think of, and so I just gave up. And these are real data, so none of you can play with it and help me. I'm just gonna give up. I know, Nathan's like, oh, I love puzzles like this. Can I try? I could send you the data if you really wanted to try, but you should work on your comps instead. That's more important. Yeah, no more.
Just get credit for natural curiosity.
Yes, I knew that you would want to, but maybe for, like, you know, your next birthday present, I'll give you the data and you can help me solve this or something.
Okay, that works. That works.
Okay, we're agreed. Comps in the meantime.
Yes.
Okay. So random intercept variance, we should have had contextual effects, but it wouldn't work. Yeah, if I add a random slope, how many of those do you think I get? One or one per submodel?
One.
One. Same
It's
deal.
proportional.
Yep. And the random slope is going the right way as well. It's predicting up. So I added random slope in the usual way. In R, I had to switch to that estimator. I did not get to do 7 points of integration. Likelihood ratio test says yes, we need it. The one in R is similar, but not exactly right, but very close. So we can take the random slope variance, throw it into a couple different things to talk about descriptive measures of how strong the variability in the slope is for within school math predicting lunch. In Logits, the slope ranges from minus 0.59 to 0.09 across 95% of the schools. That means every school has an inverse relationship between math and lunch of the higher category. Slope reliability I can do as well. That came out to 0.64. And then I have a results section about that. So a little bit on ordinal. Once you get past the headache of whether you have thresholds or intercepts, the rest of it works the same. There's nothing new. And you can use Logits as your link function. You could use cumulative probit if that's a choice, or cumulative complementary log if that's a choice. What was I going to say? I lost it. Yeah, but everything works the same as for binary other than that. Okay, questions? Okay, want to do a little bit of nominal? Like this much? This is this much? Yeah. And then we'll do counts on Thursday. How about that? So here's some words. Oh, I don't have nominal.
This real fun trick the other week.
Yeah.
Where you type like an underscore and then a letter and it turned into Greek.
Yes.
Was that what you did? Underscore the letter?
Yeah, do you want to see that?
Yeah, because I was trying to do it the other day and
Sure.
I realized like,
Yeah, I don't have nominal in here. I totally forgot. I bailed on that.
I know, but she did it even faster.
Okay, so I am going to open an equation, which you can either go to...
Oh, so you have to be in the equation feature?
Yes.
Okay. I
So-
thought it was just within the text.
Yeah, you can either insert an equation or just go Alt like that, and then you can type Greek letters by putting a slash like that,
Okay.
and then underscore, like if you wanted that, and then you hit space and it jumps into a subscript.
Thank you.
No problem. If you want to do like variances, sigma caret 2, and then hit space, and then I'm going to do underscore, and then you can have superscripts and subscripts like that. It looks nice, doesn't it?
Yeah.
Mhm.
How do we make the little, can you quickly make the little triangle that goes in -2 log likelihood?
Oh, no, I don't know
That
how to
doesn't
do that.
Okay, that's
Um,
fine.
It's
I just-
delta, but it's like when you do this, I think
That's
it's the wrong.
Greek, yeah.
It's
Yeah,
the
do
wrong.
capital D.
Okay, let me see if it does it for that. Oh, there you go. Oh, I get a round of applause for that? You guys are so nice.
So I gave up and just put -2 log likelihood.
That's fine. Well, what I do is like, so you can see all my little shortcut things I've saved up here. One of them is symbols. And I usually just, like, it's one of the most recent ones usually whenever I do
Gotcha.
delta, but yeah. Yeah, you can do, like capital letters, like if you do that, then it turns into the capital version. It doesn't read minds though, so I can't do like that.
It's SIM.
What is it?
SIM.
Squiggle.
But
Oh,
if
that's
you
a
do-
different squiggle. Yes.
Oh.
Yeah, that's good though. That's tilde. Like that one's on the
Oh,
keyboard.
that's right. That's right.
Yeah, no, I was going with, let's see if I can pull it up. So if I go to the Greek letters,
Oh, I see. Chi and zeta.
yeah, oh, I'm not, where are they? There is a Greek letter that I have affectionately named Squiggle 1, and that's right here,
Oh, Zeta.
I guess. And then there's another one that I call Squiggle 2, that's over here, because it has 2 squiggles on the top of it, and I don't know what that is either.
Underneath. But it
Yeah,
would pink
that
color.
one is XI. Psi? She?
Yeah.
I thought it was
Yeah, that-
Psi.
Oh, it's not
Yeah.
chi. 'Cause that's.
Yeah.
Not Chi. Chi is I know Psi Chi, because I was in Psi Chi, and I know that one for that
Okay,
reason
none of
only.
those three?
Yeah, that's,
It's a
yeah.
glottal.
This is where fraternities and sororities prepare you for graduate school, right? You help you learn the Greek alphabet, but no, I don't. So like in the factor analysis textbook, the author uses one of these for the latent factor, and since I can't reliably identify it, label it, or draw it, it's F in my notation, like the end. It's F for factor. But anyway,
I think that's Zeta.
okay. So I know why I didn't do nominal. We go back to this. Where is nominal? Nominal's here. Okay, so this is the idea of nominal. 0 versus 1, 0 versus 2, 0 versus 3. So one thing that makes nominal and adjacent category a little bit weird is trying to figure out how to get back to a marginal probability. So different software does this differently, and I also could not find any documentation of what to do this in R. The only package that I found was MCLogit or MICLogit, which is sort of funny. It sounds like a 90s rapper or something to me. Like MCLogit on the raps, I like it. Here's a little story on your short, I like it. You know, something like that.
I like it, I like it.
But it wouldn't tell me what it was doing, but there's a couple differences that make nominal very different as an animal. Number one is that it's always intercepts. Like the world has agreed to just change it back to intercepts. There's never thresholds given in nominal, so I like that. Number two is that there's no proportional odds anything in nominal. So that means that everything is separate across submodels. So like if you want to estimate a multi-level model predicting this outcome, how many random intercepts would you need? There's 3 categories. How many submodels?
Now,
Or
we will
actually,
have
this is
to-
4 categories in this one. 3 submodels for 4 categories. So how many random intercepts will we need?
If they are different, we will need 3,
3. And do you think they would be covariate?
of course.
Yeah, it depends on your software. In SAS, no. In Stata, yes. In R, maybe, couldn't tell what it was doing. And if I wanted to add a random slope, how many of those would I need?
3.
3. How many random effects do I have altogether at this point?
6 variances.
6. And how many covariances among the 6?
15.
A lot, yeah. 15 sounds right.
Yeah.
And how many quadrature points is that going to be for 6 dimensions?
6.
6
Power
to the
six.
power, like however many to the power of 6? Yeah. So a lot. So at this point, it would be very difficult, I think, to estimate a nominal multi-level model. I think what probably is going to be more useful is to carve things up into binary, but then you get into a weirdness with the clustering because you're pulling some people out of the cluster. So your cluster estimates would not reflect everybody. They'd only reflect the people who are in that submodel. So there's some weirdness here. But in the materials online, I did try to fit a nominal model. The reason I didn't put it in here now, it's all coming back to me, not Celine Dion, but the nominal model. Stata makes you do it in GSIM, so generalized structural equation modeling, which we have not even talked about. And SAS does not put in the covariances among the random effects. And R had no documentation whatsoever telling me what the hell I was looking at. So I'm like, all right, I give up. You want nominal? Good luck with that. I can help you individually, but I can't give you a coherent example to follow because at this point I just give up. So, but I do talk about nominal regression in the generalized class where everything is nice and simple because then there's no random effects. All right. Okay. Yeah, that's all I wanted to say about that. So next time, then what we have left is counts. I'll do a little count example using a different data set that has nothing to do with free lunch, I promise. I stole it from the Stata manual. How about that? Yeah, all right. I feel like that's a good momentum to end on. That sound good? 10 minutes extra of your life you get back?
Yeah.
Okay, well, yeah, we'll do that. All right, unless there's questions. No, all right. Then thanks for being here. Hope to see as many of you as can be here on Thursday if you're heading to a conference. Safe travels, and let me know if you need anything, but you don't have anything to do right now. It's glorious. Yay, exactly.